Cloudflare root leak incident, a DevOps Postmortem. It's January 22, 2026. Most people are just starting their day, but inside the Network Operations Center, the atmosphere is turning toxic. Somewhere deep in the infrastructure, a silent ghost has entered the machine, a massive BGP root leak originating from a single router in the Miami data center. It wasn't a gradual decay. It was an instantaneous structural failure of the Internet's map. Because of an automated routing policy configuration error, entire blocks of traffic were being shoved into a digital dead end. We aren't talking about a minor glitch or a localized hiccup here. This was a fundamental breach of the protocols that keep the global web connected. Within minutes, the unintentional advertisement of these prefixes began propagating, creating a chaotic detour for data packets across the globe. The scale was staggering, and by the time we realized how far the infection had spread, the fallout was already becoming a headline. Imagine you're running one of the largest content delivery networks on the planet. For millions of users, Cloudflare is the invisible shield, the massive infrastructure that ensures your web traffic actually reaches its destination instead of vanishing into the void. It's a high-stakes game of digital navigation where every packet needs a clear map. On January 22, 2026, that map suddenly became a maze for some people. A glitch in an automated routing policy triggered a border gateway protocol, or BGP, root leak originating from a specific router in their Miami data center. In plain terms, the Internet's GPS started giving conflicting directions. Instead of following the shortest path, data began taking scenic detours through unintended routes because of those leaked prefixes. When the backbone of the Internet loses its sense of direction, even the biggest players feel the ground shake beneath them. This wasn't just a minor hiccup, it was a foundational failure of global navigation. It was early morning on January 22, 2026, and for most of the network, everything was humming along exactly as it should. In the world of global routing, stability is the only currency that matters, and Cloudflare's infrastructure was built to maintain that status quo across thousands of hops. Then, an automated routing policy configuration error slipped through the cracks. It wasn't a manual typo by a tired engineer or a rogue script. It was a systemic failure in how policies were being validated. This glitch triggered the unintended advertisement of Border Gateway Protocol (BGP) prefixes from a specific router located in their Miami data center. On paper, it was just another routine update to the automation logic, a silent shift in code meant to streamline traffic. But beneath the surface, that single configuration flaw was about to turn a stable path into a chaotic detour for global traffic. The fuse was lit. It was early morning on January 22, 2026, when the first ripples hit the water. It started not with a bang, but with a silent, systematic failure deep within the infrastructure. An automated routing policy configuration, something that should have been solid as bedrock, glitched. And suddenly, the system began behaving like it had lost its map. In an instant, specific border gateway protocol prefixes were being leaked out from a single router in the Miami data center. To the engineers watching the monitors, it wasn't just a minor hiccup, it was a massive geographical detour for data packets. Traffic didn't just slow down, it took the wrong turns into the void. By the time the alarms finally screamed, the unintended advertisement of those BGP prefixes meant parts of the network were effectively shouting their secrets to anyone listening. The why was buried in a flawed automation script, but the what was already causing chaos across the Miami hub. It started with a single logic flaw in an automated routing policy, a ghost in the machine that nobody saw coming until it was too late. On January 22, 2026, that script malfunctioned, triggering a massive BGP prefix leak originating from a specific router in the Miami data center. This wasn't just a local hiccup, it was a systemic contagion, because these routes were being advertised incorrectly across the global internet backbone. Traffic began taking wild, unintended paths. Instead of following the intended high-speed lanes, packets were getting tossed into the weeds of the public web as the leaked prefixes propagated outward. By the time the engineering teams realized what was happening, the cascade had already moved beyond their immediate perimeter. It was a domino effect where one faulty configuration choice forced the global routing table to swallow a lie, turning a localized automation error into a widespread network infrastructure crisis. So we dig into the guts of the system and find exactly what went sideways. It wasn't some malicious actor or a stray line of manual code. It was a ghost in the machine, specifically an automated routing policy configuration error. On January 22, 2026, this faulty logic triggered a massive failure in how the network communicated with the outside world. Because the automation lacked sufficient guardrails, it began unintentionally advertising Border Gateway Protocol (BGP) prefixes from a specific router located in their Miami data center. In plain English, the internet was told that certain paths belonged somewhere they didn't, causing traffic to take a wrong turn into a dead end. By letting an automated script make high-stakes routing decisions without enough oversight, the system essentially took its own instructions literally, creating a technical detour that effectively orphaned those routes from their intended destinations. When we talk about blast radius, we aren't just talking about a localized glitch. We're talking about how far the poison spreads before someone hits the kill switch. On January 22, 2026, this wasn't a small crack in the hull, it was an open door. Because of an automated routing policy configuration error, BGP prefixes were leaked out of a specific router in the Miami data center. In the world of networking, a BGP leak is like shouting your private coordinates into a megaphone for the entire internet to hear. It didn't just affect one internal service or a single team, it compromised the integrity of the routes themselves. While the logs don't give us a precise dollar amount for the chaos, the sheer scale of leaking prefixes from a major hub means the reach was massive. For those few hours, the path of data wasn't just rerouted, it was fundamentally exposed. When the alarms started screaming on January 22, 2026, it wasn't just a minor glitch, it was a full-blown routing catastrophe. Somewhere in the infrastructure, an automated policy had malfunctioned, causing a massive BGP prefix leak originating from a specific router in the Miami data center. The team had to move fast because when your routes are bleeding into the wrong neighborhoods, every second counts. They dove into the logs, hunting for the source of the misconfiguration while the pressure mounted. It was a high-stakes game of digital whack-a-mole as they identified the faulty automated routing logic. They didn't just patch it on the fly, they had to isolate the leaked prefixes and force a correction across the network. By isolating the specific configuration error that triggered the leak, they managed to stabilize the Miami node and pull those advertisements back before the damage became permanent. So, how do you stop your entire network from taking a wrong turn into someone else's backyard? The team had to dive straight into the guts of those automated routing policies that triggered the mess. They didn't just patch the hole, they overhauled the logic governing how BGP prefixes were advertised out of that specific Miami data center. By fixing the faulty automation scripts and implementing much stricter validation layers for any outgoing routes, they effectively locked the gates. It wasn't just about fixing one broken line of code, it was about re-engineering the guardrails so that an automated mistake couldn't snowball into a global leak again. Now, every time a policy is updated, it hits a gauntlet of checks designed to catch anomalies before they hit the backbone. It's the kind of never-again architecture that keeps the internet from collapsing under its own weight when a script goes rogue. Look, if there's one thing this mess teaches us, it's that automated is just another word for fast way to fail at scale if you don't have guardrails. When that automated routing policy hit the production environment on January 22, 2026, it didn't just glitch. It broadcasted those BGP prefixes out into the wild like an open invitation to chaos. We can't treat automation as a set-it-and-forget-it magic wand. Every script that touches global routing needs a human sanity check or, better yet, a rigorous, multi-layer validation gate. You have to assume the machine will do exactly what you tell it to do, even if what you told it to do was accidentally expose your entire infrastructure map from the Miami data center. Reliability isn't found in the perfect code. It's found in the friction points we build to stop automated errors from becoming global catastrophes. Validate early, validate often, and never trust a script with the keys to the kingdom without oversight. That's how Cloudflare turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.